Hey everyone, this is Matt with Learn Everything About Design, and in today's video we are going to be scanning a part using the Einstar2. Now, one of the requested videos we had was asking about how to use global marker files. In this video we're going to be scanning a part with laser scanning. This is a black painted plastic part. We'll talk about what we can do and what we can't do without scan spray. We are going to be going through the ExHub software, so we'll talk about the setup, we'll talk about the global marker files, some maybe best practices, just kind of what I've gotten used to with using it. And we will be using this in wireless mode. So no cables attached, it's got a battery in it right now, and we should have plenty of power to scan what we need. So the first thing that we want to do whenever we get started on a project is first we need to make sure that this thing is up to date in terms of its calibration. Now, one thing I've noticed with Shining 3D, specifically with the Einstar2, is that there are prompts telling you if the calibration hasn't been done within a certain period of time. I think it's like 30 days. And so you can ignore that, you can skip it, but it's a good idea to recalibrate it every so often just to make sure that the results you're getting are the most accurate they can be. The calibration process isn't too bad. It's different than most other scanners that I've used, but it walks you through it on the screen, so there's really nothing to go through there in this video. So once you have a scanner that is updated and calibrated and ready to go, the next thing that we need to consider is our scanning area. So I have a couple of things here. Just this sort of opaque white plastic piece that I've got some large marker dots on one side and I've got a bunch of small marker dots on the other. The small marker dots can be helpful because a lot of times you can position your part so that you can see more marker dots, especially if they're smaller. You want to make sure when you do this that it is a randomized pattern, which I know humans that's really hard to do, but you'll notice that there's some clusters. There's 3 together over here, 3 over here, and there's a couple that are sort of together. If you use some sort of consistent pattern, it's not going to help the tracking, so it does need to be unique. The other thing that I'm using is something that I 3D printed, and this is just basically a flat sheet. Originally I 3D printed it to hold a coin and to hold small pieces in the center, but it's got some pyramids and some domes on it. This green plastic gets picked up by the scanner pretty well, so it will include it in the scan. But the point of this is that we've got marker dots at different angles. So that way, if you're scanning something, you can kind of set this up in the background and you get all kinds of different angles that you can go without losing tracking. So we're gonna set this up in just a little bit. The other thing that I do wanna mention is the part. Now we need to be mindful of the size of the part and the surface finish of the part. Now, this is from the GPZ project, and yes, I know it's been a long time since we've done a video on that. I have been working on it, but because it's a personal project, a lot of times I just tinker with it here and there. Not really something that I can record. We will be recording some more videos, but this is going to be the tank pod. Now, bikes in the 80s and even current ones, very rarely did they have a fuel gauge. This is actually one of very few bikes, at least from that era, that actually had a fuel gauge. It had a digital gauge that was in the tank for things like side stand switch, which is gone on the bike, fuel gauge, and a couple of warning lights, things like that. And what I decided to do was to repurpose this, and we're building a GPS speedo that's going to go in here. It will still use the fuel sender from the bike. The problem with the fuel sender is because the bike is angled further down, or the front end's lower, the back end's higher now. So it doesn't do a real good job of being accurate, but we're going to fix that once we finalize this bike. But the display that I have, the Nexian display, and the electronics they're just a little bit too big to fit in here. So what we need to do is I need to scan this, and then I can have it as a reference for designing a new part. There's a slight curve to it on the front where it fits the tank. There's a curve to it on the side. It actually has a rubber gasket that goes on it. This back corner is broken. Long story there. And there is a sort of a rounded cutout where it meets the stem or the frame where it comes up to the stem. Now this part has been repainted, not very well by me, with a rattle can years ago. And so it's got a lot of orange peel, but it is shiny black, which is typically one of the trickiest things for us to scan. It often causes problems. So when we get to scanning this thing, what we're gonna do is we're gonna scan it as is. And then we're going to use scan spray, and we're going to see how much of a difference it actually makes. Now, spoiler alert, it makes quite a big difference. All right, so once we have our part, the next thing that we want to do is we want to set up our scan area. Now, I like to keep little clear lids around from things like chain lube and spray paint cans. The clear ones work out pretty well because they don't really get picked up by the scanner. Also, really any lid will work fine. Even though a lot of times we have base removal options or ease of removing the base options when we're scanning, I find it easier to elevate the part. And so a lot of times what I like to do is just set it up on like little lids or something like this so it's just off of the base. I also like to turn it on the base. Let's go ahead and just reposition that just to make sure we can see as many marker dots as possible. The other thing I do like to do in this case is set up that 3D printed part with all of the marker dots on the back. So that way we can use it and have a reference. So the problem that we get with 3D scanning when we're using markers is as we rotate down and we get like 45 degrees from the markers, they start to lose the tracking because it just can't see them. And so if we put more marker dots on the backside, this gives us the ability to sort of see them as we're at this steeper angle. So it is important to have marker dots around. You always do want them to be on a rigid surface. I do have one of these sort of softer mats that I use from time to time. It's almost like a very thin mouse pad. And I have used this before. I think it's generally okay if we're doing like an IR scan, but with a laser scan, you really do want something that is solid and there's no chance for the marker dots to really move around, even if they are flexing. Once it's on a hard surface, it's probably not an issue, but when you're setting up, you just want to make sure that things are as fixed as possible. All right, so now that we got everything set up, the next step for us is to connect the scanner. All right, so we're going to be a little zoomed in here for this, but with the Einstar2, all we need to do is hold down the power button for 5 seconds. Now, if you just press it and let it go, the fan and everything will come on, but sometimes it doesn't power on completely. This is also true when you're shutting it off. You want to make sure that you hold it down for at least 5 seconds. It'll do some, turn the fans on, it'll make some flashing lights and things like that, and then just make sure that the light goes completely off. There's just a very faint blue light right in the middle. It starts flashing when it's trying to connect. On the software, there's also a button that we can click. If you are having connection troubles, you can go ahead and hit that and make sure that it connects. It is over Wi-Fi 6, so you will need to make sure that the Wi-Fi on the computer you're using is on, even if it's not connected to the internet or a network. You do want to make sure that it is on. And that way it can find this, and you may need to go through your Wi-Fi settings for that. Once we have it connected, we're going to start a new project group. And I'm going to call this my GPZ tank pod. And I'm going to just put video after it so I know that this was from recording. And we'll confirm that. Once we have that, the next step in this process is to pick our scanning mode. Keep in mind that when we make a project, or really when we create these groups, it is laser scan or IR scan only. And in this case, we're going to use all laser scanning, so it doesn't really matter. But whichever one you pick, that is the one for that group. Now, if you've not used the ExHub before, there is this pop-up, and I'm going to leave it on, but it kind of tells you what the buttons do. There is a lot of things that you can do, like double click for quick operations, plus or minus for brightness and things like that. I generally don't fool with that because I will forget it. I use so many different devices and different programs that remembering what a single click and a double click is going to do on this is not going to do me any favors. So I'm just going to leave it alone. The next step in this process is for our project, we want to set up our scan settings. Now, there are two modes that we have. We've got markers and we've got global markers. When we scan with markers, what this is going to do is track the markers in real time. It will add them, basically it'll use those for all the tracking that we want to do. When we use a global marker file, global markers will allow us to scan just the markers first and not capture any point data. And then it'll make a global marker file that will know where all those are. And that lets us scan relatively quickly It also allows us to do things like jump around the part much faster without losing tracking. So the global markers can be extremely handy. There are some nuances here. For example, the global marker file is not saved automatically. So for example, if you go into open a global marker file, you will need to manually save that and if you want to re-access it. So what we're going to do is global markers. We're going to scan the global markers. Brightness, I'm going to use medium, and we're indoors, so I'm not going to use outdoor mode. The brightness you'll need to play around with because I've got such a fairly bright hex light above us. I don't need to go to a full bright. But once we're ready, we'll simply press play and it'll start the preview. We're not scanning yet. We can move around. Nothing's really happening until we hit the play button again. Now you want to pay close attention on the left-hand side. Blue means we're too far away. Green is sort of a good range and yellow is too close. And so it kind of mimics the distance you are away from the target in this case. So you want to get in that green range, press the play button, and then we're scanning the markers. And you just want to move around. You want to rotate and kind of go up. Now the scanner is actually supposed to be in this orientation. So if you want it to match the screen, just kind of hold it upright. Once you have all of them, hit the play button again and it'll pause. Now once it's paused, we can take a look at the markers that we have on screen, and if we're happy with them, we're going to move to global marker optimization. And so this is just going to go through, clean things up, and once we're ready to use it, the next step in the process is to click Scan Point Clouds. Now, you'll notice one step in that process, I did not save the global marker file externally. At that stage, before we move on to scanning the point clouds, that's the point where you would want to save it externally if you wanted to reuse it. In this setup, because I'm covering markers on the center of this board and the object is fairly large, I'm not going to save the marker file. We can save the next one just so you can see how to do it. But it's really not going to do me any benefits because this is not a fixed setup. This piece can move. The orientation can change, so it's never going to be the same no matter how I put it together in this case. So I don't really want to save it. One thing that is not instantly apparent is when you click on Scan Point Clouds, you can actually scroll down and the rest of your scan settings are below there. So it's not, again, if you're here, you may think, okay, I don't really know what to do from here. Well, just scroll down and then you can see all the rest of your settings. There is an Add Global Markers option, which means that as you're scanning, if it picks up extra markers that weren't in that global marker file, it can actually add and use those. I got all of them, so I'm not really worried about it, so I'm going to leave that off. We're going to use normal scan targets. You also have a reflective option. So this is basically your part. This part is not really reflective, it's shiny, but it's not like a shiny metal, it's paint that's dull and orange peel. So I'm not worried about using reflective. We're going to use the standard brightness, which is right in the middle. We can change it on the fly with the plus and minus. And I'm not worried about texture. In this case, a quality indicator I will leave on. Outdoor mode, local enlarged view, I'm going to leave all these off as default. And then when we're ready, all we do is press the play button. Again, this is going to start a preview. We're not scanning yet. Again, we want to get in that green area. You'll notice this is actually closer than it was with the global marker file. We were a little bit further away. And once we're ready, we just hit play and start scanning. Now, one thing that's going to be instantly apparent if you do this is you need to maintain a perpendicular position to the part you're scanning. And so that's going to get pretty tricky in some areas, like back here where I've got this 3D print in the way. And we're just going to move back and forth, and we're going to go over to the side. And again, you can kind of see here, we're struggling with tracking, so I'm going to rotate around, kind of move forward and backward. Now remember, the Einstar2 is parallel line only. There's no cross lines, there's no single line mode. And if you're scanning in parallel line only, my personal suggestion is to make sure that you scan the surface in two orientations. You want to actually make your own cross lines. So I'm going to go back and forth. We're not going to do this whole part without scan spray because I know that it's going to be much better with scan spray. So I'm only going to do this side, or this one scan like this. But basically, again, you got to be careful of the targets and you want to try to be perpendicular, kind of move back and forth. And you also want to go, again, change the orientation of those lines. You want to always try to maintain that perpendicular relationship, which again, easier said than done, especially in this setup, because I cannot get the scanner down here without being occluded. So I kind of made a problem for myself. I'll fix that in the next scan. Again, I'm not going to go fully through this because it does a much better job with scan spray, but we can at least see what we got here. And so if we rotate this around, what we're going to do is I'm going to clear out the cap. And so to do that, I need to hold down Shift, and I'm just going to go ahead and cut that part out, hit delete. And then I want to select, hold down Shift again. I'm going to select just a part of this, select everything that's connected to that domain, and then invert the selection, and then delete the selected items. So that's going to be the quickest way for me to get rid of all that extra stuff. There's some stuff that's floating around in here. You can see there's some lines here. Again, this is why we want to scan it in 2 directions to kind of help that out. Once we're done with a little bit of this cleanup, we're going to apply. And then after we apply those changes, the next step is to move on to generating a point cloud. Now, there's 2 ways we can do this. There's generate, and then there's generate and optimize. I'm going to use the optimize. It uses a little bit more memory, a little bit more processing time. Honestly, on a part this size, it's not really that bad. So we'll just let it crank a little bit. But what that's going to do is it'll give us a point cloud that we can work with. Again, it's not required that you use things like this to stand your part off, but I do find it really helpful when you're going to clean things up because it makes it much easier to do any sort of cleanup here. All right, so here's the point cloud. Again, I didn't spend a ton of time because I wasn't really worried about using this scan because I know it's going to be better with the scan spray. But honestly, I think this looks pretty good. There's some surfaces on the inside where it caught just a little bit of that inside that we could clean up, and on that side as well. But overall, I think that's actually a really good result. You can see the backside's pretty good as well. So let's go ahead and take a look at doing this with scan spray. So first we need to go back to our project list. This is project 1. We're going to add a new project. Once again, all the projects in our group are going to use the same scan mode. So laser or the VXL mode, the IR mode. Once again, we're going to use global markers, but first I need to go ahead and put some spray on here. I have one spray can here that's holding it up, but here's another. The brand doesn't really matter. I do suggest using vanishing scan spray. It helps with the cleanup. This stuff here is permanent classic white. I found the classic white does really well. There are other colors that work as well. But scan spray definitely is expensive, but it goes a long way. I will also say that you can use other things. I've used baby powder, and you need a carrier that evaporates, something like isopropyl alcohol or acetone. Acetone is usually a carrier in some of these aerosols. You can also use, I've heard of people using things like athlete's foot spray or spray on deodorant. Just keep in mind that you have to clean that up afterwards. And that's why the vanishing spray for me works so well, because it just makes the job a little bit easier. So I'm gonna go ahead and spray this. I'm gonna do it away from that. And I should probably hold it underneath. You don't need a lot. You just wanna basically get a dull finish. There we go, put that back. All right, and then you want to be careful not to touch it. If you touch it, it's okay, but the problem is then it's gonna just smear and leave a shiny spot, so it's not what we want. I'm gonna try to get this a little bit further away from that back so I can get a better scan. And then you need to let it sit. I got a little bit heavy right here. I should have had the can a bit further away. It'll still scan just fine. See if we can get it to clear up a little bit. And then we'll run with that. All right, so let's go ahead and scan the global markers. So once again, preview. Start scanning. I'm gonna get all the stuff on the back, the stuff on the side. It can actually see the markers inside of the object, so that can be pretty helpful as well. Just move around, make sure you get them all. Once you got them all, we're going to go ahead and optimize. And then if you want to save the global marker file to use it again, then what you do is you say export scan. It's not going to be a point cloud or a mesh, but it's going to be the global marker file that you can bring back in. Again, I'm not going to do that because this will never be in the same setup again. So I'm going to scan point clouds, scroll down and just double check the settings. And then once again, we're going to press play, which will start our preview, and then press play again to start scanning. And so instantly you can see that it's turning blue relatively quick. It's not really struggling to get any of the plastic. It's not black anymore. It's not shiny anymore. It's got the dull finish. We do still generally want to scan in two directions. I think that's just kind of a universal thing, I would say. And it does a bit better at not being completely perpendicular to the surface. And so that's another thing to keep in mind. I'm going to go ahead and just come over here. I'm going to do this back and forth. There's a little bit of, I don't know, it looks just like some noise on top of that area. And we'll go over here. That's probably more than enough. All right, and once again, we can cut out the stuff underneath pretty easily. Hold down Shift, and I'm just gonna kind of separate this from the base. And then we want to select that, connected domain, invert, and hit delete. And that should take care of most of the extra floating stuff. And then from here, I'm gonna generate and optimize. While that's optimizing, something that we should talk about when we're scanning plastic parts like this, if we need the inside detail, this tends to get pretty tricky. There's actually like epoxy or glue that held the gasket on, but it tends to get pretty tricky to get multiple scans for the inside and the outside. And so what I would say with that is you can certainly use scan spray on the inside, that'll help. Anytime you can get the entire lip as well as some of the sides, that will help with your alignment. So what I'm gonna do is I'm gonna spray the inside. I don't need the outside anymore, at least this area. So I'm gonna try to hold it. Let's see how I can hold it. Good news is now my finger can scan pretty easily. Whew. Oh, there's some cobwebs in there too. Cool. All right, so this one's good. We could generate the mesh. I'm not done with that one yet, so we're gonna go back to the project list. I'm gonna create a new project. Now remember, every project is gonna have the same scan mode. For this one, I'm gonna go ahead and use markers instead of global marker just to show the difference. Again, I'm going to turn this so I can try to get as much as possible. Get these out of the way, I don't need them. And this time we don't have to really scroll down to get to our settings. We just want to start over here. Again, we're previewing. Once we're ready, hit play, and we'll start scanning. And so you can see we're picking up loads of markers. Because of the scan spray, we're getting a lot of detail pretty quickly. You do still need to be mindful of being perpendicular to your scan or to the object. That's just a thing that you're always going to have to do. And then we want to try to roll over and get some of the other side. The negative part of this, or the downside to this, is it's going to make alignment when we put multiple scans together. It could potentially make some problems for us because what ends up happening is where the edge of our available scan meets the other scan, you're gonna have a lot of like just roughness and texture that's not really there. So we wanna try to get all the inside and all the outside as much as we can to help with alignment. I don't really need the inside because the new gauge pod, is going to have its own components inside. I'm not paying attention here. So I don't really need the mounting bosses and all the stuff on the inside. I only really need the outside shape. So I'm just going to work my way around and try to get everything I have here. Make sure I get these corners, which are pretty tricky. But you can see here, even though I didn't use global markers, it's doing a really good job of tracking. Not really any slower. I can't jump all the way around the part, but it's doing a good enough job of tracking everything. So we'll pause. This one, because I did not have it standing off, like it wasn't sitting on anything, it's going to be a little bit trickier. But let's try connected domain, see what, so it got everything here. So we don't want that. So let's go ahead and deselect. Let's try to get rid of the bottom here. And just cut that off there. All I really need is the inside, so I'm going to just go ahead and grab that. Connected, invert, delete, takes care of most of it. A lot of this stuff on the outside we need to get rid of. Oh, you can see there I got rid of some stuff, so got rid of some stuff I shouldn't have. So I got to be a little bit more careful here. So I'm going to come over here, delete that. Delete that. This stuff doesn't really matter. Oop, it's caps lock. Delete that. All right. Invert. All right. So it's still a little messy on the inside. Let's go ahead and allow it to optimize the point cloud, and we'll see if it's able to clean it up. All right, let's go back to our project list. I do want to mention one more thing before we move on. All the projects inside of your group, all of them will contribute to the mesh that you're generating. And so that's something where you have to be careful. If you are scanning a bunch of different scans and you don't necessarily need all of them, then what you want to do is right click on the project, and you've got two options basically. Remove, which will remove it from your group, but it keeps it saved inside of the folder on your local machine, or delete, which will delete it from here and from your computer completely. So I'm going to use remove, which gets rid of it from the group, and we should be able to re-import that if we need it. It's not something I've actually tried to do yet, I'll be completely honest, but it did leave it inside of the folders for me. So the next step for us is going to be alignment. So we're going to move over to alignment, project 2, project 3. I'm going to let it do it automatically, see if it can find a correct solution. And it looks like it does. So you can see, zoom in here. These edges right here may potentially cause us a problem, so we'll just have to see. I'm going to apply that and exit. And so now both the projects are aligned. If I hide one, they're in the same location. So the next step for us is going to be to turn this into a mesh, which is going to be mesh model. The first step is going to be essentially taking the raw data that we have, or the point cloud, and then configuring it how we want to turn it into a mesh. Now there are a couple of options here for filtering. So what I would say is standard filtering typically works the best. I'm going to use medium in this case because I do see that I've got some floating stuff over here. Next is smooth, standard, medium, and high. We have the ability to do some of these steps afterwards, so we don't have to commit everything here. Remove small floating parts. I'm going to increase that to 30. Again, there's a lot of like little things floating here. Max triangles, I don't really care about that. I just wanted to create a mesh. We can simplify it after the fact. Remove spikes, fill small holes, and there aren't any markers on the part. I tend to avoid that, but we're going to just leave that on just in case, and we're going to preview. So now it's going to take all of our settings. It's going to go through the process of taking our generated and optimized point clouds of the two scans, the top and the bottom, that are aligned, and then it's going to give us a mesh. Now, if we're happy with this mesh, if we zoom in and we take a look and everything looks pretty good. So right here, this little seam and this piece right here, that is basically the overlap from the underside scan to the top scan. So we could go back and we can clean that up and remove some more, getting it away from this corner. For our purposes, because I am not exactly replicating this part, I just need, essentially I just need it where it fits the tank and the rough angle of the gauge, because I'm going to redesign it completely. This is going to be good enough for me. But if you needed a better scan, that is the reason that that's there, is because the underside scan basically ended right where that edge was, because when we were scanning, we couldn't go around that corner. And so if you need to clean that up, then that's what you would do, is go back to the points. Everything there looks pretty good. Kawasaki logo looks pretty good. This edge could be better, but that's probably a result of my scan. I've got a lot of detail on the inside. And so I'm happy with that, so I'm going to confirm that. Now, once we confirm the mesh, we can just export it at this point if we're happy with it, but there's a whole host of mesh editing tools. Texture adjustment is grayed out because I didn't capture texture data, so that's basically the color. The simplification, so basically you can see what the size is going to be of the original and simplified version. So you can use this slider and it'll give you an idea of the file size. You can preview everything before you confirm it. And one thing that you want to look for is areas where you've got a lot of detail. So like, for example, the Kawasaki logo. Now, if you need to keep that for some reason, you want to pay close attention and make sure that you're not losing detail like that. For us, this is going to be fine. I'm going to confirm. Next is optimization. And so once again, we've got a slider here. And anytime there's a little tooltip, what you can do is you can hover over this and it'll give you a little bit more information. The tooltips are relatively short, but what mesh optimization is doing is basically in large areas, we don't need very many triangles to capture the data, but in areas where we've got a tight fillet or curvature, those are the areas where we need more triangles. So mesh optimization, it looks at essentially optimizing the density of the triangles in areas where it's needed and reducing the density of those triangles in areas it's not. So again, play around with these settings and make sure that you're preserving the edges that you need. Confirm it. Next step is smoothing. So what this is going to do is, remember the original model I told you had a lot of orange peel? And what smoothing is going to do is, if you think about orange peel on a painted surface like a car, when you start sanding, you're taking all the high points and you're taking them down until you get to essentially the low point, and then you've got a smooth finish. What smoothing is actually doing is it's taking those high points down, but it's bringing the low points up as well. And so it's a little bit like sanding, but in this case, because it's a mesh, what we can actually do is pull points up and push them down and get a smoother end result. And so once again, you want to pay close attention to anything like logos and text and hard corners that you need to keep. You can see we're probably losing some detail back here. Once again, I am not concerned with the overall shape for what we're doing, because I'm going to be creating a completely new part. So I'm happy with the smoothing. And the next stuff we have here is like small floating parts. All of that was stripped out already based on the original mesh settings. We've got auto hole filling, we've got manual hole filling, flipping the normals, cutting plane tool, mirror, and zoom. All of these things you can go through. In our case, it's not really applicable, so we're not gonna use them here. So at this stage, if we're taking it to another software like Quick Surface Pro, which we are going to use, we are going to take this part over there to do some modeling and pulling out geometry, then we can just export it now. If your next step is to go directly to a CAD program like Fusion or SolidWorks or Inventor, then you may want to go to the next step, which is measurement. So as you look over here on the right, you can see export scan if we want to send it out, share your scan if you use the online ExHub, you can do that. And then you got model display, which is essentially just doing a 3D view of your model so you can take a good look at it. For us, the next step would be the measurement process. So if we want to, say, align this to X, Y, Z, then the measurement process is where we extract, we need at least a plane, a line, and a point. And so it's tricky because this isn't really a flat part in any sense, but what we can do is we can try to generate a plane. So we're going to use create feature. Point, I can create a point wherever I want the coordinate system to be, so I'm not really too worried about it, but I'll go ahead and just put a point here for the purposes of this. We'll create it. For plane, I'm going to try to basically pick 3 points on the back side where the gauge goes, because that is a fairly flat area. We'll create a plane there. And then for the line, what you can do is you can manually draw a line, or if you create a couple of planes, you can use the intersection between 2 planes. Because I don't really have any other flat features that I can use, what I'm going to do is I'm going to manually draw a line along this edge and create it to use for my alignment. So once you have those 3 features, I'm just going to rotate this around. Then we want to go to align. We're going to use the 3-2-1 system. So plane 1, our line is going to be line 1, and our point is going to be point 1, and we're going to align this. So what this allows us to do is we put the coordinate system exactly where that point was. Its Z is normal to our selected plane that we created here, and X is along the line that we created. And you can see here X minus and Z minus based on the orientation. And then once that's aligned, again, you can hit align again, close it. And so now when you export this, if you look at the view cube down here in the bottom, when you export this, it's going to be aligned to whatever coordinate system you used. So now that we have our mesh, we've cleaned it up, we've aligned it, we're going to go ahead and export the scan. I'm going to save it locally. Again, if you happen to use XModel or use any of the Shining 3D online stuff, then you can go ahead and export it there. I am going to go ahead and put it in a folder where my data sets are. If I can find it. So this would be GPZ Gauge Pod video, and I'm going to save it as an STL. And in terms of the other formats, STL is triangle only. There's no image, texture, or color data that goes with it. If you are capturing color data, then you likely want to use an OBJ or one of the other formats. All right, we gotta get this done real quick because the camera overheated. So that's gonna be the end of it. If you have any questions, please let me know. I'm gonna leave links in the description for all of our stuff, our affiliate for Shining 3D, courses on our learneverythingaboutdesign.com, and our merch store. If you want a Will 3D scan for Tacos t-shirt or any of our other stuff, make sure that you check out the description of the video. We'll leave all that stuff down there. As always, thanks for watching, and we'll see you in the next one.